In this module, titled Introduction to CyberChef, we'll delve into the fundamentals of CyberChef and understand why it is often referred to as the Cyber Swiss Army knife. Our journey will be guided by SecuriTech. CyberChef caters to a diverse audience, including developers, security analysts, and IT professionals. Whether you're a seasoned coder, someone dealing with security protocols, or an IT jack of all trades, CyberChef provides a versatile platform to enhance your data manipulation capabilities efficiently and intuitively. Let's get ready to dive into the details and explore how we can leverage this powerful tool to simplify complex operations, such as encryption, encoding, and compression. And CyberChef is a powerful web application designed for performing a multitude of data manipulation operations. But why should you consider using CyberChef? It offers an intuitive interface that makes complex data tasks more approachable, even for those who aren't experts in coding. From encryption and encoding to compression, CyberChef provides a wide range of operations that can simplify your workflow. Whether you're a developer, a security analyst, or an IT professional, CyberChef can be an invaluable tool for handling data in various forms. Installing CyberChef locally. Now let's talk about how you can install CyberChef on your local machine. There are two primary methods for using CyberChef. Firstly, you can use it directly through its live demo, which is accessible via a web browser without any installation required. This is perfect for quick tasks, or if you prefer not to set up any additional software. Secondly, if you prefer to have CyberChef set up locally, you can do so using Docker. This involves running a few simple commands. First, you'll need to pull the latest CyberChef image from GitHub's container registry with the command shell docker pull ghcr.io/ghq cyberchef latest. Then, you can run CyberChef with the following command, which will make the application accessible on port 880 of your local machine. Shell docker run -p 8880 ghcr.io/gch/cyberchef latest. This Docker setup is straightforward and ensures that you have the latest version of CyberChef with all its features available locally. In this slide, we will be going over the main interface components of CyberChef. Understanding these components will allow you to efficiently use CyberChef for various operations. Firstly, we have the input box. This is where you can input text or files that you want to process. Next is the operations list, which provides a categorized set of operations that you can easily access and apply. In the center, we have the recipe area. Here, you can drag and drop operations to create a sequence of tasks that CyberChef will execute in order. Finally, there's the output box, where the results of your operations will be displayed. This allows you to see the immediate effects of the operations you've applied. Familiarizing yourself with these components will make your use of CyberChef more intuitive and effective. Let's dive into basic operations, focusing on encoding and decoding. In this section, we'll cover base64 encoding and decoding operations. First, let's talk about base64 encoding. For this operation, we use the command to base64. When you input text such as hello world, the output will be the encoded string sgvsbgsivciq. Base64 encoding is essential for ensuring that data remains intact without modification during transport. Next, we have base64 decoding, which is the reverse operation. Using from base64, you can take an encoded string, such as sgvsb88ifcmxkiq, and decode it back to its original form, hello world. This process is crucial for interpreting data that has been encoded. These basic operations are fundamental for various tasks, including data transmission and storage. They ensure both the integrity and the readability of the data. Now, let's dive into compression and decompression operations, specifically using gzip. Gzip compression allows us to take a string of text and compress it into a smaller binary format. For instance, if we have the input hello world, the gzip operation will transform this into compressed binary data, saving space and potentially reducing transmission times over a network. On the flip side, we have gzip decompression, also known as gunzip. This process takes the compressed binary data and restores it back to its original form. Using our earlier example, applying gunzip to the compressed binary data will give us back the string hello world, restoring the entire message to its original readable state. These operations are pivotal for efficiently managing data storage and transmission, especially in scenarios where bandwidth or storage space is limited. Now moving on to advanced cryptographic operations. First, we have AES encryption. In an AES encryption operation, you provide input data, in this case hello world, along with a password, such as my password. The output is encrypted binary data, which can only be decrypted using the same password. Next, we'll look at RSA decryption. For an RSA decryption operation, you will input the encrypted data that you received earlier along with your RSA private key. The result is the original message, such as "Hello World." Both of these cryptographic methods are essential for securing your data. AES for symmetric encryption, where the same key is used for both encryption and decryption, and RSA for asymmetric encryption, which involves a public and a private key. Now let's dive into the topic of data parsing and analysis. This slide covers two essential operations: IPv6 parsing and timestamp extraction. First, we'll look at IPv6 parsing. When you input an IPv6 address, such as 2001 DB885A3 8882E2377334, the parsing operation processes it and outputs the parsed IPv6 address. This is crucial for handling and analyzing network traffic that utilizes IPv6 addressing. Next, we cover extracting timestamps. This can be done using regular expressions or by converting Unix timestamps. Extracting timestamps is particularly useful when you need to analyze log files for forensic evidence, such as pinpointing specific events based on time. By mastering these parsing and analysis techniques, you'll be better equipped to handle complex data inspections and troubleshoot network and system issues efficiently. In this part of the course, we're delving into hexdump and binary operations. These conversions are fundamental in various fields, including cybersecurity and data analysis. Firstly, let's look at hexdump conversion. This operation involves converting binary data into its corresponding hexdump representation. For example, if you start with a given set of binary data, the output will be its hexdump form, which is essential for tasks like debugging or data inspection. On the flip side, we have binary conversion. This operation involves translating hexdump representation back into binary data. This is useful when you need to revert hexdump data to its original binary form for further processing or analysis. These conversions streamline the handling and interpretation of data at a low level, enabling more effective analysis and manipulation. Now, let's discuss how we can automate CyberChef using Node.js. The first step is the installation, which can be done via npm with the command npm install CyberChef. Here's a simple example script that demonstrates how to use CyberChef in a Node.js environment. Start by requiring CyberChef. JavaScript const chef equals require CyberChef. Next, define your input data, which in this case is the string hello world. JavaScript const input equals hello world. Now, specify the recipe you want to apply. For this example, we'll use to base 64. JavaScript const recipe equals to base 64. Finally, bake the input with the specified recipe. JavaScript const result chef.bake input console.log result output sgv7sxmxkikgia. As you can see, the result is the base64 encoded string of the input text. This setup allows you to automate various data transformations using CyberChef recipes directly within your Node.js applications. In this slide, we delve into some of the advanced features that CyberChef offers to enhance automation and efficiency. First, we have automated encoding detection. This feature allows you to detect various encodings in your input data and decode them with just a single click. An example of this is the magic operation, which can automatically handle encoding without manual intervention. Next, we cover the use of breakpoints. Breakpoints enable you to set specific points in your recipes for step-by-step debugging. This is particularly useful for troubleshooting complex operations. An example of this would be the breakpoint operation, allowing you to pause and inspect the state of your data at any point in the recipe. Lastly, CyberChef allows you to save and load recipes. This feature is invaluable for repeated use of the same set of operations, ensuring consistency and saving time. You can save your recipes as .cyber files and load them whenever needed for similar tasks. These advanced features significantly enhance the functionality and usability of CyberChef for various complex operations. Now, let's explore the practical applications of the advanced features we discussed previously. One essential area is forensic analysis. In forensic investigations, extracting meaningful data from logs is crucial. For instance, you might need to extract timestamps from logs using operations like regex and converting from Unix timestamp. This is especially valuable in a real-world scenario where you need to analyze log files for forensic evidence. By automating and streamlining these tasks, you can enhance the accuracy and speed of your forensic analysis efforts. In this section, we're focusing on penetration testing, a critical area within cybersecurity. We'll illustrate how decoding multiple layers of encoding can be pivotal in understanding and thwarting potential attacks. The core operation we'll discuss is magic, which involves advanced techniques for identifying and decoding various encoding schemes used by attackers to obfuscate payloads. Imagine encountering a suspicious payload that has been encoded several times to mask its true intent. By using techniques that decipher these layers, we can reveal the true content and purpose of the payload. This method is often used in real-world scenarios to detect sophisticated attacks where payloads are hidden within seemingly benign data. Understanding these operations allows us to decode complex payloads, which is essential for identifying and mitigating security threats in penetration testing exercises. In this section, we're focusing on data transformation. Consider an example where you need to convert a hex dump into readable text and then decompress it. This transformation is crucial in operations where raw data is often encoded or compressed. Here, we use tools and techniques like converting from hex dump and decompressing with gzip. A real-world scenario where this becomes highly relevant is in reverse engineering compressed data files. By converting the hex dump back to readable text and decompressing the data, we can gain insights into original forms that can be analyzed further. These skills are key in dealing with encoded data streams, ensuring you can accurately reveal underlying information without data loss or corruption. Next, we'll discuss contributing to CyberChef. If you're looking to add new operations to the tool, you'll need a basic understanding of JavaScript. This knowledge is crucial for creating and integrating custom operations. To contribute, you can add these new operations via GitHub. This platform allows you to collaborate effectively with other developers and enhance CyberChef's functionality. Furthermore, you're encouraged to engage with the CyberChef community on GitHub. Participation can involve reporting bugs, suggesting new features, or even helping other users. This collaborative environment ensures continuous improvement and support for CyberChef, benefiting everyone involved.